Section 7.3, triangle similarity. There's 3, angle, angle, side, 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 and side, angle, side. These are the objectives. You can go ahead and read. I'm losing my voice. Vocab, no vocab. First, postulates, postulate 731. This is actually a shortcut. Up to now, you have learned how to show that two polygons are similar by using the definition of polygons, definition of similar polygons on the previous section. But now, if you have a triangle and you have two angles that are congruent, two corresponding angles that are congruent, then you can conclude that the triangles are similar. This is what this postulate is saying, and we also call it just angle, angle. Let's move on to the next slide. It says explain why the triangles are similar and write a similarity statement. So this is what you, this is how you can explain number one. It says that we know that angle BCA, which they're talking about this angle, is congruent to this angle ECD, and they are congruent because they're vertical angles. Also, angle A and angle D are congruent because they're right angles, or by the right angle congruence theorem. Therefore, we can conclude that these two triangles are similar by angle, angle postulate. Next slide. Same directions. So here we go. So you know that angle C is equal to 43 degrees. I mean, it's 47 degrees. Why? Because of this. So now you know that angle C and angle F are congruent. Also, angle B is congruent to angle angle B is congruent to angle E by the right angle congruence theorem. Therefore, we can conclude that these two triangles are similar by angle, angle postulate. Similarity postulate. Let's move on to the next slide. This is theorem 732, and this is another shortcut. This is side, 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 or SSS similarity. And I'll read it. It says if three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. 733 is another shortcut. Side angle side, or side angle, or SAS similarity. I'll read it. If two sides of one triangle are proportional to two sides of another triangle and their included angles. Here we go back with included angles, something that you have seen on a previous section, previous chapter. And included angles are congruent, then the triangles are similar. Let's go on to the next slide and apply these. This is verify that triangle PQR and triangle STU are similar. Notice that we have PQ and ST are corresponding sides, and they give us the same ratio. I mean, they give us 2/3 as a ratio. QR is corresponding to TU, and again, they give us the same ratio as the previous one. And at this point, go with the last corresponding sides. PR correspond to SU, and is also equal to 2/3. So now, we can say that triangle PQR similar to triangle STU by side, side, side theorem, similarity theorem. Number 4, verify that triangle DEF and triangle HJK are similar. So here we go, and it's given that those are 70 degrees, so that's why they are congruent. Now we go with those two corresponding sides, and notice that they gave me, it simplifies to 2. Those are two corresponding sides. It is also equal to 2. Therefore, we can say that these two triangles are similar by side angle side similarity. Next slide. Since verify that those two triangles are similar, first we can say the following, that these two angles are congruent because they are vertical angles. At this point, I can say that Tx and Vx are corresponding sides, and they give me this ratio 3/4 once I simplified. In the same manner, these are corresponding sides. When I simplify 15/20, I get 3/4. So now I can say that these two triangles are similar by side angle side similarity theorem. Next slide. Let's explain why those triangles are similar and then find CD. So here's my CD. So first, prove that the triangles are similar, and I know that these two triangles are similar by angle. Why? Because they have both have a 90-degree angle, and also they share this side. So I can say that they are similar by angle similarity postulate. Then I need to find CD, so I'm going to use the following proportion. Notice that I'm setting them equal to each other because they're similar. The ratios are equal to each other because the ratios that they're going to generate should be equal. So when I set a ratio equal to another ratio, we call that a proportion. You learn this in pre-algebra. So now I'm going to do is I'm going to substitute. And before I actually cross multiply, I am going to simplify, and this is what I get. Now I cross multiply, solve for x, and then at the end I need to solve for CD, which is just basically this. And I'm done with number 6. Next slide. This is number 7, the last problem. Let's explain why these are similar and then find, RT. So we know that these two triangles are similar by angle similarity postulate. And again, these angles are congruent and they share this angle R. So they are similar by angle similarity postulate. I set up my ratios equal to each other. I substitute. First of all, actually, I label ST as distance XT as X. And then at this point, this is what I write. 10 over 10 plus X. Notice that RS is 10 plus X. And then this is just 8 over 12. Before I cross multiply, I simplify. And then I'm going to work with this. I cross multiply, and then this is the equation that I get. I distribute the right hand side, and I solve for x, and I get x equals 5. And I'm pretty sure you know how to find x. Very simple algebra that I'm skipping. And then at this point I'm not done. I still need to find RT. So RT is this. So RT is equal to 15. The last slide is just so I guess there's one more, number 8, and this is a proof. This is actually not too bad. So you're given that that information, and I'm trying to prove that these two triangles are similar. So here we go. Given at this point, I can divide both sides by 3RT, and then this is what I get. I get UT over RT is equal to 5/3. Then I write the second given. I divide both sides by 3ST, and then I get the following. And notice that these two ratios give me the same ratio. And if you go back to the picture, these are ratio of corresponding sides. In addition to that, I can say that these two angles are congruent because they're vertical angles. Then at this point I'm basically done. Why? Because these are similar because of side angle side similarity there. And I'm using, if you go back, this is the side angle side are highlighted on steps 2, 4, and 5. This is the last slide. This is something for you to read and make sure you understand what this is saying. This concludes the video.